Hello and welcome to the video about wiring solar panels in series or in parallel. Let me explain the different pros and cons of each method so that you can make the right decision. First, we will take a look at the basics of a series connection. In this image you can see how a series light circuit works. The negative from the first light is connected to the positive of the second light. The negative from the second light is connected to the positive of the third light, and so on. If one wire breaks, all the lights will stop working. In a parallel connection, all the positive wires are connected to each other, and all the negative wires are connected to each other. The wires come together in a combiner box. If one of the wires from the light breaks, the other lights will still work. If you want to wire solar panels in series, you connect them the same way as a light circuit. You can look at this diagram how it's done. If you're wiring in series, the volts are added up and the current stays the same. That's why you don't need to use a thicker cable. Let's say each panel is rated at 20 volts and 5 amps. That means that the output of this series connection is 60 volts and 5 amps to the charge controller. Make sure the voltage is under the maximum allowed input voltage of your charge controller. This is usually 100 volts for an MPPT charge controller. In a parallel circuit, all the positive and negative wires go to the combiner box, or they are connected via special MC4 connectors called branch connectors. This will make it easy to do maintenance if you have to remove a panel or add some more to your setup. The downside is that you have to install a combiner box or branch connectors and make it waterproof. If you use the same panel at 20 volts and 5 amps each, we get an output to the charge controller at 20 volts and 15 amps. If you wire in parallel, you need a charge controller that is able to handle the larger input current, which will be more expensive. There will also be a minimum starting voltage for the charge controller. Therefore, you must verify that the connection that you are choosing is both able to meet minimum and maximum voltages, as well as maximum electrical current input to the charge controller. If you use a PWM charge controller, wiring in parallel is more common because of the limit on input voltage. Always check your wire thickness if you use parallel. Standard wires might not be enough for the amount of current you send through it. Now, you might think that series is the best connection to make because it will reduce your wiring cost. That is true if there is no shading. If, for example, there are 3 solar panels and one has shade, the whole string will suffer a reduced current output because shade has impact on current, not voltage. If you expect shading to happen, I recommend using smaller panels, a parallel setup or a hybrid setup. In the diagram we can see that the leaf will have a big impact on the total output power of the series connection. In a series connection, the panel with the lowest amount of output current will be the current for all panels. The one panel will literally drag down the current of the other panels. This is why different models of panels should never be connected together, since this will limit the current, voltage and power of the module. A hybrid setup, also called series parallel setup, combines series and parallel connections. This can be useful on a boat. If you have a total of 4 panels, place 2 panels on port and 2 on starboard. You would then wire 2 in series and then combine both of the series strings in parallel. If there is a sail that casts a shadow, then I recommend wiring all your panels in parallel. It's going to be more expensive to wire and your charge controller will be more expensive, but you will get a higher efficiency. If your panel experiences low irradiance in the morning and evening, The voltage might not reach the minimal threshold of your charge controller to start putting energy in the battery. Remember that a series connection adds up the voltage while the current stays the same. In a series connection, the voltage would reach the minimum input threshold of the charge controller quicker than in parallel. So a series connection will likely put more energy in the battery during early and late sun hours. In this matter, there is another factor to consider, which is the voltage drop. The longer the wire from the panels to the charge controller, the higher the voltage drop will be. If the setup that you have chosen is all connected in parallel, having very low voltage and the panels are located far away from the charge controller, then the setup might not have enough voltage to reach the minimum value of the charge controller. The voltage is also affected by temperature. If the temperature of the location is hot, voltage will drop, while if the temperature is cold, voltage drop will be minimal. If you find yourself at a hot location with a long distance between the panels and the charge controller, then a series connection might be the best option. Another option is to increase the diameter of your wires. Bottom line, if you choose between series or parallel, you have to keep in mind the shading conditions and the type of charge controller you are using. If you expect shading or use a PWM charge controller, choose parallel. In all other cases, go for a series connection. Place as many panels in series as you can, while keeping the maximum input voltage of the charge controller in mind. If you go over the maximum input voltage, wire it in a hybrid setup or use another charge controller and link them so they work together. Thank you for watching this video about series and parallel connection of solar panels. If this video was helpful to you, please press the like button, subscribe if you want to see more of these, and I will see you in the next video.